So this video is about some different kinds of problems we can see that deal with scientific and standard notation. So we're going to talk about two types: tricky examples that deal with scientific notation, and also word problems that deal with scientific notation. So the first thing that I want to talk about is the tricky examples. So somewhere on your notes, above where it says tricky practice, we're going to talk about some tricky examples. I'm going to kind of go through these examples with you. Tricky examples. So here's our first example. Let's say we have something like 188 times 10 to the fifth. 188 times 10 to the fifth. Now looking at this, this is not, it looks like it might be in scientific notation, but it's not. Remember that scientific notation needs to be a number, then a decimal point, and then after that decimal point we might have some more numbers, times 10 to the and a power of 10. Just a power. So we might have, for example, a 2 here. Right now, this is, we have a power of 10, but we don't have a number and then a decimal. So when you have to deal with examples like this, we need to first put them into scientific notation in order to do anything with them. So the first thing that we're going to do is we're going to put number in scientific notation. So I'm going to go to this number, and I know the decimal is going to go between the first and the second number. So I'm going to rewrite that as 1.88. Now, we can't just add a decimal and bring down the 10 to the fifth power. We have to adjust because we just moved the decimal place. So the second thing that you want to do is you want to adjust or figure out exponent. And I'll explain what that means. What we're going to do right now is figure out, okay, if I wanted to make this number right here back into 188, how many places would I have to move this decimal? If I wanted to go from 1.88 back to 108, how would I do that? Well, I'd move my decimal 2 places to the right. 1, 2. Because of that, I'm going to times this by 10 to the second power. Because to move this decimal back to here, I'm going to have to move it 1, 2 to the right so that my decimal was here. So what I'm doing there is I'm going to times by 10 to the second power. Now I still need to deal with this 10 to the fifth, so I'm going to bring down 10 to the fifth. That's my third. Bring down original exponent. I'm going to bring down my original exponent. My last step is I need to simplify. So what I mean by that is I'm going to bring down my 1.88. I have times 10 to the, I can't just leave 10 to the second, 10 to the fifth. I know that since these are being multiplied, I can add my exponents, 10 and 5. So this is actually 10 times 1.88 times 10 to the 7th. Okay? And that's how I move something that's not in scientific notation to be in scientific notation. So let's do another example. What if we had something like 0.0034 times 10 to the fifth? Well, right now, this is not in scientific notation. I need to move this into scientific notation. I know my decimal is going to end up being right here because that's between the 3 and the 4. So I'm going to go ahead and rewrite this. 3.4 times. The next thing I want to do is adjust or figure for my exponent. I should say figure out exponent. So from this decimal to this decimal, how many did I move? I moved 1, 2, 3 to the left. That's going to be 10 to the negative third. My third step, I'm going to bring down my 10 to the fifth. And then my last step is I need to simplify. So 3.4 times 10 to the, well, right here, I need to say, okay, this is going to end up being, if I put these together, 10 to the Negative 3 plus 5. Negative 3 plus 5 is 2, so 10 to the second. And there's my number in scientific notation. Now, a really great way to make sure that we're right is to check these on the calculator. Right now on your calculator, I want you to type in 0.0034 times 10 to the fifth. Type that into your calculator. 0.0034 times 10 to the fifth. All right, let's see. 0.0034 times 10 to the fifth. That gives me, when I do this, I get 340. I should get the same number when I double check down here. So 3.4 times 10 to the second is also 340. So because these are both right, I know I did it right. So let's add a fifth step that we should probably check our answer. Make sure that we're adjusting it right. Okay, I'm going to go ahead and erase these steps because I want to do one more example for you, so make sure you have these written down. Okay, one more example. Let's say I had something like 0.00052 times 10 to the negative sixth. Well, right now, this is not in scientific notation, so I need to put it in scientific notation. I know my decimal is going to go in between the 5 and the 2. So I'm going to have 5.2 times 10 to the, how many spaces do I move from this decimal to this one? 1, 2, 3, 4. 4 to the left, so 10 to the negative fourth. I need to also bring down my 10 to the negative sixth. I need to simplify, so 10 to the negative fourth plus 10 to the negative sixth, that's going to give us 10 to the negative 10th. And our last step, the step we just added, is let's make sure we get the same number. So let's do 0.00052, 0.00052 times 10 to the negative sixth. And if you type that into your calculator, the number is so big that the calculator gives it back to you in scientific notation. You should see on your calculator 5.2 times 10, and on the calculator it looks like this. 5.2 times 10, negative 10. It looks like this. This is how the calculator does scientific notation to abbreviate it. If you're using a graphing calculator, it can say 5.2, and then it has an E, negative 10. That is just scientific notation. So when you check it, you might also have a number so big that it gives it back to you in scientific notation. And that's okay because we figured it out and these match. Okay, what I want you to do right now is try these two practices. I'm going to go pause the video, try the examples, and then press play. All right, here are your two examples and the answers. Double check that you got it right and write down any questions that you have. Okay, we're going to do two more examples, and those are word problems. Now, sometimes you get a word problem, and it's going to have scientific notation in it. You just have to make sure you understand what all the different phrases mean. So example 1 says, imagine you are a scientist in the town of Star Wars. Convert each number from scientific notation, I'm going to use cups as I read, scientific notation to standard notation, or vice versa. All right, so let's kind of remind ourselves what all these things mean. Scientific notation, that looks like you having a number and some numbers times 10 to the power of something. Standard notation, that's just going to be the number itself. Vice versa means that you might go back and forth. So you might go from this to this, or you might go from standard to scientific. So now let's read the question itself. The planet Hoth is so cold because it is 55 million miles from the sun. Okay, right now, is this standard or scientific? This is standard. This is the number itself. So right now, we need to go from standard to scientific notation. And I'm going to use SN to represent scientific notation. So I'm going to take my 55 million. Okay, remember my steps are I'm going to place a decimal, between the first and the second number, so 5.5. So it's going to be 5.5 times 10 to the, and I'm going to see how many places I got. 1, 2, 3, 4, 5, 6, 7. I went 7 to the right, so that's going to be a positive 7. Alright, let's try this. Yoda can use the force to move objects as much as 4.5 times 10 to the 11th kilograms. Oh, and I'm sorry, before we start this one, I forgot something really important up here. See if you can figure out what I forgot. Right now, we're dealing with units, so we have to include our units. We need to put the word miles after this. Okay, make sure you include units. Okay, I'm sorry, so let's keep going. Yoda can use the force to move objects as much as 4.5 times 10 to the 11th kilograms heavy. In standard notation, this weight is. So it wants us to write it in standard notation. Well, I know standard notation is the number. I know that this is scientific notation. So I need to go from scientific notation to standard. So I'm going to go ahead and rewrite this. 4.5 times 10 to the 11th. So in order to go from scientific to standard, first thing I'm going to do is rewrite my 4.5. I know I'm going to move 11 to the right because it's a positive. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oop, I'm going to run out of room. 10, 11. That was a lot of lines. Let's double check we did 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Anything that doesn't have a number, I'm going to fill in with zeros. Okay, and this is looking like a pretty big number. Remember, we don't want to leave it sloppy like this with lines underneath and a decimal point. So I'm going to rewrite it. 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a big number, so we need to add our commas. So start on the right-hand side and put commas every 3 numbers. And lastly, we need to include our units, kilograms, so kg. So here is 4.5 times 10 to the 11th in standard notation. Okay, what I want you to do is try these 3 practice problems. Go ahead and pause the video, try the 3 problems, and press play when you're ready. Alright, here are the answers. Go ahead and check them, write down any questions you have, and be ready to practice during class.